Hello. So in this video we're going to have a look at resistance. So please make sure your phone is off, you've not got TV on, you're not playing any games or anything, and you've got a pen and paper ready to do some questions at the end. If you're ready, we shall begin. So what should we know already? There's a couple of things we should know already about electric circuits that are important for this topic. We need to know about current. Now, current is the flow of charged particles. Normally, electrons going through a circuit. So wires or the components in there, so the light bulbs and everything. And it's that flow of electrons. It goes at the same speed, but the number of electrons can change. And obviously, we measure current in amps. Give that the symbol A. Now, potential difference, this is the trickier bit. So this is the difference in electrical energy between 2 points in an electric circuit. So if we have a circuit, we're going to draw one out. We've got our cell here, we've got our wires. I've got a light bulb here. I've got my completed circuit. My light bulb will be on, so we can see the light coming out of it. And we'll say that this is a 6-volt cell. So we have 6 volts going round. Now to measure my potential difference, we're going to measure it using a voltmeter. And it's measured in volts. Now, unlike current, where the current will be the same at all points in the circuit, so it could be 4 amps here, 4 amps up here, 4 amps here, 4 amps here, 4 amps here, 4 amps here, because it stays the same. My potential difference will be different around the circuit. And it will lose that potential difference, that we'll get to see that potential difference happening across a component. So we'll measure my symbol for a voltmeter there, my potential difference across my circuit. So if we imagine my current is going round, my electrons are going round this way, and they're going to come through here, through here, through here, and back to here. We can have a look at what the potential difference will be at each point. So at this point here, it will be 6 volts. At this point here, it will be 6 volts. At this point here, it will be 6 volts. However, going across my light bulb, it's going to use that electrical energy to light up the light bulb, and we'll get 0 volts on this side, and we'll continue with 0 volts, 0 volts, and 0 volts. Gets back to the cell, gets another push again, and we get up to 6 volts. Got that energy back. We're back up to 6 volts, 6 volts, 6 volts, and then down to 0 volts as we go across here. And that potential energy is transferred from electrical energy to light energy and a bit of heat in my light bulb. And it's lost it all by the time it's gone past the other side. So we have a difference across the light bulb. Now, resistance is the thing we're looking at in this video, in this lesson. So resistance is something that decreases the current. It makes it harder for the electrons or charged particles to pass through it. It doesn't slow it down, it just decreases it. So we decrease the number of electrons passing through. We're not going slower, we're just getting less of them going through. And we can think of it a bit like this. So we've got our volt, our potential difference. So this is our potential difference. We've got our current going through here. And this bit here is our resistance. You can see as we're going through, at this point, so before we reach the part that's got the resistance in, we could fit a lot more electrons going through. So we could get a larger current. through this bit here, our resistance has gone down. So we're going to decrease the number of electrons going through this point. As such, it will slow down, it will decrease the current in the entire circuit because less electrons will be able to pass through each point per unit time. Now, resistance is measured in something called ohms. This word here, ohms. And just like with current and potential difference, we had symbols to write it. We have a symbol for ohms as well. Now, we don't use the letter O, as you might expect. We use this symbol here. This symbol here is omega. It's the Greek letter omega. We like using Greek letters in science. And that omega is the symbol for ohms. So this symbol here is the symbol for ohms. We're now going to have a look at how we can calculate resistance. So we use the equation. Potential difference equals current times resistance. It's important I've given it this way because I think it's the easiest way to learn it. And we can write it out. We can go V equals IR. So V equals IR. And it's the easiest way to remember this equation. Now we can obviously rearrange it. If we wanted to make current, or I, again, for some reason we use the letter I for current. I is the symbol for current. Don't ask me why. Very, very confusing, but it is. We wanted to make current the subject. So to find out current, we would rearrange it. I'm not going to go through a rearranging for you, but it's I equals the voltage or the potential difference divided by the resistance. If we wanted to make the resistance the subject, which you will need at times, again we would rearrange it to have the potential difference divided by the current. You've got some options. You can either learn all three equations or you can just learn one of them. Again, I think this one here is the easiest one to learn, V equals IR, and learn how to rearrange it. So the rearranging is a skill that is really, really worth learning. If you're unsure how to do it, we'll do some sessions on it, and your maths teachers will go through it with you as well. So we can then rearrange the equation to make anything the subject. And that allows us to find the potential difference, current, or resistance within a component. So we're now going to have a look at one of them here. So calculate the resistance of a light bulb if the current is 4 amps and the potential difference across the lamp is 6 volts. So we're going to think, right, I'm going to write down my equation. V equals I, my current, times R, my resistance. V equals IR. And let's see what I know already. So I know my current is 4 amps. I know my potential difference is 6 volts. So I know now that I can either write them all down, so I can go my potential difference is 6 volts, my current is 4 amps, and my resistance, I don't know yet. But I can then put them into the equation, or I can rearrange the equation first. I'm just going to put them into my equation. So I'm going to have 6 volts equals 4 amps, my current, times by my resistance. I'm now going to rearrange my equation to make R the subject. I will get R, my resistance, equals 6 volts divided by 4 amps. I can now do that on my calculator, so do 6 divided by 4, and I will get 1.5. I need to remember my units as well, so I can either write it as ohms, OHMS, or I can use my symbol omega. And that is how we can calculate equations, calculate the resistance using the current and potential difference. You're now going to see 10 questions for you to have a go at completing, either going to calculate the resistance, the current, or the potential difference. Make sure you read it and make sure you know which way round, which equation you're going to be using and which one is the subject. The questions are here. Please pause the video and complete the questions. When you're ready, press play and we'll go through the answers. So you should now only be watching if you have completed all 10 questions. If not, pause now, because we're going to move on to look at the answers. So here are all the answers. You can mark them yourself. Remember, you need to make sure you have the units on there as well, whether it's ohms, volts or amps. Well done if you got all 10 of them correct. If not, look at the ones you got wrong and think, did you use the right equation? Had you rearranged the equation in the right way? Thank you very much for watching. I do hope it has been useful. Don't forget to subscribe to the channel. Thank you very much. Bye-bye.